Okay, if you made it this far, we are beginning the start of the systems checks. Now, as I said, sims are perfect, and also a lot of stuff is not implemented in reentry properly or just not at all. So we have the system checks, and of course, if you run them, it's not going to actually give you any procedures. Um, but basically, it's going to tell you, hey, run these checklists. And these are actual checklists. Um, However, I'll just teach you how to run through them instead of queuing up the individual checklists. You guys can find them on your own. Like for example, here's caution and warning ops check. You can queue up SMRCS, CMRCS, um, cryo PSI quantity, and the only thing I would need to pull up is the CMRCS check here. So yeah, so first, actually, you know what? We will just queue them up. Why not? So basically, you see perform CWIS check. We'll just pull that up, and then we'll click the run on top button. There we go. So caution warning system operations check. Do a lamp test. Make sure all the lights turn on. Make sure all the lights turn on. You're going to verify the master alarms are behaving properly. Left and right. And then you're going to set this to CM. Give the alarm the push. Make sure these two lights light up. And that's because we haven't pressurized the CMRCS, and that's good. Done with the caution warning check. Now you'll queue up your service module RCS monitoring check. So there's a series of valves here, helium bladders to keep it pressurized, and the propellant. Please note that secondary propellant, as you can see, does not get any talkbacks, only the primary. So if you close the primary and you turn on the secondary, like, you're not going to get any talkbacks for that. Secondary is only used when you have less than 50% RCS, which, if you manage that in reentry, holy crap, because you basically have infinite RCS. So, starting off, it says SMRCS helium talkbacks 8 gray. We've got 1, 2, 3, 4, 5, 6, 7, 8. System 1 and System 2. Just going to make sure all those are gray on quads A, B, C, D. Very good. Now we'll make sure that our primary propellant and secondary propellant talkbacks are gray. Again, secondary propellant fuel press does not have the talkbacks. It's only associated with the primary propellant. Secondary fuel press is only for bringing up the pressure when you're less than 50% quantity. Now you'll click through the RCS indicators, make sure all the temperatures are good. Temperature should be 115 to 175 degrees Fahrenheit for the temperature. Helium pressure should be just recorded, actually. Secondary fuel pressure should be 178 to 192. And then here we're on quantity. They should all say 100. Now you'll flip to helium tank temp, and you'll just verify that the tank temp on those... helium tank temp, actually we'll just record those. Again, helium systems are not implemented in reentry, so this is just set to some arbitrary value. In real life, with this kind of temperature, we'd be expecting tank temp on the helium about up to here. So you're going to go ahead and do that, and then the checklist tells you to open these if you're not paying attention and reading, that is. Don't open those. Ensure they are closed for this portion of the flight. Next up is perform CMRCS monitoring check. So go back, we'll queue up CMRCS check, and we're not going to run it because this whole front of the checklist is useless. We don't need the CMRCS, so we should make sure that these talkbacks are not gray. They need to be barber pole, or the isolation valves for the propellant should be closed. That's what that reads. And pre-press conditions are helium pressure stable at 3300 to 3500 psi. Sorry, that's after activation. Sorry, before activation, we're looking for a temperature of, and you can see this readout is useless. We're looking for a readout of 60 to 90 degrees. On helium tank temp, which is red here. Now secondary fuel is not displayed here. It's a little confusing now. But that's pretty much good. 60 to 90. Actually, no. Sorry, helium temp. Sorry, we're looking at CMRCS here. Helium temp is here. And it is currently, this is times 100, so yeah, good. 60 to 90. And then the helium pressure should be 41 to 42. 100 RCS, our pressure. Good. And then the manifold here, the fuel pressure manifold, or helium manifold rather, should be 80 to 105. We've got it at about 105. So number 2 is good, and number 1 is also good. So we're good there. Yeah, the CMRCS stuff can get a little confusing because it switches the entire meaning of the whole gauge. So it's, you only use it once, so it's not really something you'll be 100% familiar with, so just make sure you're keeping up with those checklists. Next up is your electrical power system, cryo PSI quantity check. So under systems EPS, we're looking for cryo PSI quantity check, and here we can run. H2 pressure indicator for both tanks should be in the green. O2 pressure should be in the green. If we switch to tank 1, should also be in the green. So number 1 displays both tank 1 and our surge tank. Our surge tank is basically any excess oxygen that is not used from the from any demand from the heaters. The heaters will heat up the supercritical oxygen and turn it into gaseous oxygen, and the any of that gaseous oxygen which is not used is stored in the surge tank and can be used by the primary cabin repress or emergency cabin repress system. Again, different than the repress package. It's also used for some other functions, such as pressurizing the suit loop. But that's what that surge tank is for. It's basically just a quick tap of already gaseous oxygen, whereas the primary tanks are not liquid, they're actually supercritical. You don't want liquid in space because it bunches up, so it's supercritical oxygen. And then you're just gonna, verify that the quantity at this stage of the mission makes sense. Record those quantities, and then you'll do a test on 4 alpha, which is the battery manifold pressure, battery compartment manifold pressure, and we do need to vent that. As the batteries are charging, they will produce helium gas, or not helium gas, my bad, hydrogen gas, which is explosive. So you would need to vent the battery compartment every once in a while. After that, you can verify that the battery relay bus has good volts. And that's it. Next up is a fuel cell power plant check. So we can queue that checklist up. Fuel cell power plant check. And here, pretty much, it's very simple. You don't even need the checklist for this. You just verify that all 3 of these cells show needles in the green. Done. That's it. DC volt amp check. Yeah, here it's going to give you, ton of stuff. You're going to verify main bus ties are off. You're going to verify you've got 1 and 2 tied to main bus A, 2 and 3 tied to main bus B. Then you're going to go through and check the volts and amps on the 3 fuel cell buses, the 2 main buses, the 2 battery buses, which these should be 37. Battery C, which should also be 37, but is slightly higher in reentry for some reason. And then the pyro bats, which should actually be 40 at this point and not 37. So it looks like bat C and pyros accidentally got flipped here. And that's pretty much it. Now you'll do your AC check. We're not even going to use a checklist for that. That's just this knob right here. Verify you've got 115 volts on everything. And it's very good. This spacecraft has 2 AC buses with 3-phase AC. You've got your Theta Alpha, Theta Bravo, Theta Charlie, and bus 2, Theta Alpha, Theta Bravo, Theta Charlie. 3 phases. Much of things only require 2 phases, but there is some stuff, such as the fans and the compressors, which would require 3 phases. They're able to run on 2 phases, however, anything less than 2 phases will actually automatically just completely trip all of the circuit breakers. It doesn't in reentry. It does in NASP, however. So if you, for instance, pull those, this 3rd one would automatically trip out. Then you would need to turn the piece of equipment off, plug the circuit breakers back in, and start it back up. Last, and certainly not least, the SPS check. That's going to be... And I can never remember where this is. That's environmental control system check. GNC. Nope. Nope. Service propulsion system. Here we go. Systems propulsion. That's obvious. That's right here. Just going to verify the temperatures are between 45 and 75. You wouldn't need to turn the heaters on at this point since we're not going to use the engine. But if it were less than 45 degrees, you would turn on heater A only. If it's greater than 75, keep it off. If it's 0, A and B, to heat it up quickly. Then you're going to verify your helium pressure should be 3,900 psi max. So nothing over that. That's good. And now we'll hit the nitrogen system. So helium pressurizes the fuel in the service propulsion system. Nitrogen actuates the valves on the injectors. So nitrogen, we want to make sure that's 2,900 psi max. We can see that's good, and system B is good. The service propulsion system has an unlimited number of ignitions, only supported by how much nitrogen you have left to actuate those valves. At this point, you'll make sure your REAC circuit breakers are open so you can't accidentally shut down a fuel cell if you bump the switch, and then you'll close this COAS tunnel lighting main bus B bus tie circuit breaker, which is just open for launch for a reason I'm not entirely sure of. And that is it for your systems checklist.